Okay, perpendicular lines. Very similar to parallel lines, except the slope is going to be different, okay? So the slope of perpendicular lines are opposite reciprocals. And I'm going to explain that. I want to do a couple examples of opposite reciprocals so that you know what I mean by that. So let's do just a quick couple of examples here. Okay, so given the slope, let's make a table. We're going to do perpendicular slope here. Okay, so if I give you a slope, then you should be able to give me a perpendicular slope. So let's say 1/2. Opposite reciprocal means we flip it over and we change the sign. So 1/2 becomes 2/1. Negative becomes positive. Positive becomes negative. Do I need that 1 underneath of it? Not really. Can I leave it there? You can, but we don't usually. Okay? What if I gave you -5? Okay? We'll flip it over. Well, how do I flip over a 5? What's the denominator on a 5? The denominator on a 5 is a 1. So we're going to flip it over. It was negative, so it becomes positive. Okay? That's what I mean by flip it over, change the sign. What if I gave you 2/3? It was positive, so now it's negative. Flip it over, 3/2. That's the perpendicular slope. -5/8. Flip it over, change the sign. 8/5, and it's positive. Okay, that's what I mean by opposite reciprocals. Okay, so you might want to write that down so you're sure you understand that part. That's the part I see people having trouble with. The rest of it is just like doing parallel. And so I'm going to do one example here. Okay, so here's my example. Write an equation. Of a line perpendicular to y equals 2/3 x plus 7 that passes through point -1, 3. Okay, for those of you who are conceptual learners, let's graph this first and kind of get an idea what we're looking for here, okay? So I'm going to graph this line. I'm going to graph the blue line. Then I'm going to graph that point, and I'm going to try to draw a line that's perpendicular to give us an idea what we're looking for, okay? So let's see if I can do this correctly. Let's go switch to black. Straight line for a y-axis. And a straight line. Oh, this is my problem. For an x-axis. Okay? Now let's graph that blue equation. So we're going to start at 7. Whoops, that's not what I meant to do. Ugh. Let's start at 7. 1, 2, 3, 4, 5, 6, 7. There's my starting point. Up 2 and over 3. 1, 2, 3. Or I could go down 2 and to the left 3. 1, 2, 3. Then I'm going to connect that blue line with the straight edge and arrows on either end, and I'm not going to make a wimpy line. Now this time though, we need something that passes through -1, 3. That's perpendicular. So let's graph that -1, 3. So -1, oops. Okay, so I changed colors again. I can't seem to figure that out. I'll have to work on that. All right, -1 and 3. 1, 2, 3. I need something perpendicular. That means it hits at 90 degrees, and it passes through that point. So it's going to look something like this. Okay? But I can't tell that exactly, and I can't draw it perfectly perpendicular, so we're going to have to use some algebra to figure out this blue line. Okay? So we're going to do the same thing we did before. Number 1, find your slope. Well, in this case, that pink line, which I tried to make a blue line, the slope was originally 2/3. But this time we're talking perpendicular slope. So remember now we have to do perpendicular slope. Perpendicular M. Let's make it this way. Oh, this little symbol, this upside down T, I should tell you what it means. That means perpendicular. Perpendicular slope. We flip it over and change the sign. So it's -3/2. Okay? First step just like before. So this is the slope we need to use. Second step. Second step is to find and label the point. Well, what point did this line go through? It went through -1, 3. So let's label that, find it, and label it. X1, Y1. There we go. Now we just need to put in our parts for the point slope form of the equation. So y minus 3 equals -3/2 x minus -1. Now again, if I don't tell you to put it into y equals mx plus b or in slope-intercept form, then you can leave it in point-slope form. But for this one, let's go through and get to slope-intercept form, okay? So this one is a little harder because we got y minus 3, and we got a little bit of a fraction in here, -3/2, and that really means x plus 1. First thing I'm going to do is distribute that -3/2. Okay? So now I have -3/2 x minus 3/2. On the other side, we still have y minus 3. Well, the last step is to get that y by itself. So I'm going to add 3 to both sides. Well, there's a couple ways you could do this. You could use your calculator, and you can hit -3, divide by 2, hit your math key. Oops, that's not what I want to do. Plus, we forgot to plus, plus 3. Then hit your math key, choose frac by hitting enter, takes you back to your home screen, and you hit enter again. Okay? Again, the calculator is a tool so that we can move on. We can leave room in our working memory to work on the algebra. If you needed to do this by hand, it would be -3/2 plus 3. We'd need a common denominator. So our common denominator would be 2. So this would be 6/2. Then we would have our denominator of 2, and 6 minus 3 is 3. You can get that answer either way. I highly recommend you get used to using the calculator so that when you're on the SAT, you don't have to use your working memory to remember how to do fractions. You can use the tool you're given, and you can move on to the higher level thinking. So your final answer here is y equals -3/2 x plus 3/2, or 1.5. That would have been impossible to figure out by just looking at the graph. I'm pretty close. It looks pretty good because here's where it would be. Let's go back to our graph. Our y-intercept's 1.5. I couldn't ask for any better, but I can't really just guess from there. That's why we have to use the algebra to make sure that what we got is a correct answer and that is absolutely specifically correct and that we're not just eyeballing it. Okay? So there's how you do that. You could do some more practice with that, but that's how you find perpendicular lines.